Hey, check this out. Here's a pretty normal looking website, right? Well, under the hood, it's hiding a serious flaw. If I run this script and wait a minute, bam, admin credentials. Now, all I have to do is log in. And we're in. Here's how we did it. What's going on, guys? Welcome to Netsec Explained, and in this video, we're going to cover everything you need to know about blind SQL injections. If you're thinking, I already know SQL, but what are blind SQL injections? Then this is the video for you. So first, what is blind SQL? Well, in a union-based SQL attack, the application returns data back to the user. This is how we find things like the database schema, credentials, and other useful information. But in blind SQL injections, we don't get that. In fact, the application doesn't usually return any useful data to us at all. So instead, we're going in, well, blind. But not all is lost. We can still query the database and cause some subtle changes in the way the application responds. The idea is that we craft special queries to ask yes/no questions. If the answer is yes, then we get response A. If the answer is no, then we get response B. This is called A/B testing. Now, there are a handful of ways we can do this A/B testing, but the two most common ones are content-based and time-based. Basically, can we get response A to return a string or element that's not in response B? And for the time-based, can we cause the application to delay its response based on a true value? Let's take a look at how both of these work. In the last video, we took a look at PortSwigger Academy. If you haven't been there before, go there. Create an account right now. It's free and you really want to have access to this if you're even remotely interested in web security. Okay, once you're logged in, we're going to take a look at the blind SQL injection with conditional responses challenge. In this scenario, we're told that there is an SQL injection vulnerability in a tracking cookie that we need to exploit. They also tell us that we can identify when the SQL injection worked by looking for this welcome back message. Finally, our goal here is to log into the application with the administrator account credentials. So, with all of that out of the way, let's see how we can do this. I'm going to go ahead, click Access the Lab to spin up a new version of the lab. And the first thing we want to do is take a look at the application. So we can see different filters, looking at toys and games or tech gifts. And we also see this My Account page where we'll look to log in. So I'm going to go back to Home and let's take a look at this in Burp. So I'm going to open up Burp, take a look at my proxy, history, and here is root request. So to show you the difference for our A/B testing, I'm going to go ahead and click Send. This will give us our welcome back message. Now I'm going to send this to compare, and then I'm going to delete the cookies just to show you how our A/B testing works. I'm going to go ahead and click Send, and you notice there's no welcome back message. So let's go ahead and send this to compare as well. Compare is a very useful tool. I use it all the time. I highly recommend using it more often in your own assessments. So I'm going to click Words, and I'm going to sync the views. And you can see the difference is in the left message where we had our cookies, we get the welcome back message. In the right, we don't. And if we continue to scroll down through the rest of the request, there's no other differences. So that's how we're going to perform our A/B testing, is looking at this welcome back message. Cool. Let's go back, take a look at repeater. I'm going to click this back button, delete the session just to make things easier. Now, because we were told that there's SQL injection, one of the first things we want to do is test with our or 1 = 1 or and 1 = 1. So in this case, we're going to use a single quote to close out that string. We're going to type in and 1 = 1, and then we're going to finish off with the comment character --. So I'm going to go ahead and click Send. And you can see we have one match. What's super useful is if you click this little gear and click auto scroll to match when text changes. It makes things a lot easier because it's going to go automatically jump to where our welcome back message is. So we can set and 1 = 2. This is going to be our B response, our false response. I'm going to go ahead and click send. Notice there's no welcome back message. And if I redo that and set it back to 1 = 1, click send, it jumps straight to our welcome back. So this is how we're setting up our A/B testing. Now, to ask the database questions, for example, what the value of the administrator's password is, we're going to have to perform some substring questions. So what that's going to look like is we're going to type in and. I'm going to put this in parentheses, and you'll see why in a moment. But we're going to do our select and then substring. I don't know what the password value is yet, but we do know that the administrator or the username value is going to be administrator. So let's take a look at how A/B testing works with just the username. So I'm going to do username. This is going to be the first position, so the first character of the username, and we only want it to return 1 character. And then here we can finish out the rest of our query from users where username equals administrator. Close that out. And then we know the first character of administrator is going to be A. And then we'll round this out with our -- character, which is already there. So this is going to be our true value. The first character of administrator is A. So we're going to go ahead and click send, and we get welcome back. If we change this to another character like B, right? The first character of administrator is not B, so this is going to give us our false response. Likewise, we can look for, say, the third character, so that would be M. Go ahead, click send. Here's our true response. And then if I change this to N, here's our false response. Another thing that we can do is, instead of looking for A through Z, we can start looking for ASCII values. So what are all of the printable characters that could possibly be in the username? This includes capitals, lowercase, symbols, and numbers. So if we look up ASCII Table, then just going to zoom in a little bit. Then we can see that decimal character 32 through 27 are all of the printable characters. We see the space, exclamation, 0 through 9, A through Z capital, A through Z lowercase, and then of course all of our parentheses and curly brackets. So decimal 32 to 127 is our printable characters in ASCII. So let's jump back to Burp. So we can type in ASCII. We'll surround just the substring. And now we're not looking for a specific character, we're looking for a number. So for example, the ASCII value for A is 97. We can click send. And this is giving us an error because I misspelled ASCII. There we go, there's our true value. And if we tried character number 98, here's our false value. Just to show you one more time how I got that, look at the ASCII table. We can see A as decimal character 97. So say we want to automate this, we can go ahead and send it to Intruder. I'm using Burp Community. I know a lot of people on my channel use Burp Community as well, so I'm not going to show you what this is like with Burp Pro. It's much faster, that's the only difference. But instead, we're going to capture this character value. We're going to change our payload to a number, and our printable characters is numbers 32 through 127, and we're going to step by 1. So we're going to go ahead and start our attack. This is just a warning in Burp Community saying that it's much slower than Burp Pro, which is quite all right. And you can see that it's making one request at a time, and it's changing the payload values. Here we can see payload 34, we see payload 37. Awesome. So while this is going, let's get it to filter out our welcome back message. So I'm going to go to this grep match and I'm going to flag the items. I'm going to go ahead and clear this, and it is a capital W, welcome back, exclamation point. I'm going to add that in, jump back to our results, and it's going to add this new column. We can already see that welcome back indeed shows up in the response where we had character 97, which is our letter A. So here's character 97. We can see welcome back is in that response. So we can sort by welcome back. I'm going to let this continue running until it's finished. I'm going to go ahead and speed this up and I'll show you the results. Cool. This took a couple minutes, but we can see that character 97, which was our ASCII character for the letter A, does indeed return with that welcome back message. So this is just a quick and easy way to show you how we can do our A/B testing with Burp Intruder. Again, with Community, it's a lot slower than Burp Pro, but don't worry about that, because instead we're going to go ahead and write a script that's going to do all of this for us. So I'm going to open up VS Code, and I have a script planned out. I'm going to walk you through beat by beat, just to kind of understand and explain what's happening at each stage. So here, the first thing we're going to do is import our request library, which is going to let us make web requests. We're going to import the sys library so that we can print to the command line interface, and then we're going to do some URL parse in order to URL encode our values. The next thing we want to add in is we want to set our target. We already identified that our ASCII range 32 to 127 or 126 is going to be all of our printable characters. Character 127 is the delete key, but I'm going to go ahead and enter that in anyways. And then we have our payload. Just like in Burp, we are changing up our position at each stage. So we're going to check position 1, position 2, position 3, and so on, from users, where username equals administrator, and this is for the password. And then we're going to change our characters from 32, 33, 34, and so on. Next, we're going to add in our proxies. So we're going to port everything through Burp. That way we can keep an eye on where things are, and if we want to dive a little deeper, we can do that without having to make the request in Python and then make a separate request in a browser. So everything's just going to go straight through Burp. And then we're going to set our cookies for our tracking ID. The next thing we're going to do, and I think this is very important, is we're going to create a class. Now, a lot of tutorials I've seen online don't do this, but trust me, after a career worth of making tools, it's good to build tools that can tie into each other. And the best way to do that is to build them all into their own individual classes. So I'm going to type in class SQLI. If you haven't worked with classes, that's quite all right. The first thing you need to know about classes is we have to define our initial state. So in this case, our class, when we build it, is going to take in our target, which is going to be the URL that we're testing against, and then the position of which character we want it to test. From there, we're going to go ahead and craft our query. So this is going to take our original SQL string, and it's going to change the position to whatever position we're setting for the class, and it's going to change the character based on a for loop that we're going to change later on. So we can see position and character, and if we scroll up and look at the SQL string, we see position and character as our variables. Awesome. After that, what we want to do is make the request. So we're going to create a function to get the request. In this case, we're going to create a new set of cookies with the tracking ID, and we're going to set the payload as basically the same payload, including the query, and we're going to URL encode that with this quote plus function. From there, we're going to do a get request. This is the request.get, we're going to follow our target. We're going to not allow redirects. We're going to set our proxy to the burp proxies we set earlier, and then our cookies from the change in the tracking ID that we set earlier. And then just because of burp, we're going to do the verify false so that we don't get errors saying that we have an invalid certificate. If we find our find string, so that is our welcome back from earlier. So if we see the string welcome back, then we're going to return a 1. If we don't see that, then we're going to return a 0. Simple as that. Finally, we're going to define our run function. So run is going to unpack the ASCII range, 32 to 127, and then we're going to do a test value for each element within the range of 32 to 127. Just so that we can follow along and see how this is going, we're going to do a write. So we're going to write our test character, and then we're going to do a backspace just so that we can see the character updating as we're going along. And then we're going to actually perform our query, and we're going to do our get request. So here is our query, and we're going to craft a query with that test value. And remember, this is where it changes the character at each iteration. And then we're going to do our request. Now, if our request returns with a 1, that means that we found a character, then it's going to return the entire run function with the value of that character. So if we put in decimal character 97, that's a lowercase a, and this is going to return the character lowercase a. Now, if we go through this entire for loop and we don't see anything, then we're just going to go ahead and return. So this is going to return blank, which essentially doesn't add anything to our output values. So now that we have all of that, we're going to go ahead and start. By Python convention, if we're running this script alone, we're going to type in if name equals main. So that looks like if name main. And then from here, we're just going to let the user know that we're starting our script. We're going to set our output to include our password as just a little prompt so that people know. From there, we're going to go ahead and start a for loop. So this is going to let us test characters number 1 through 25. And so in each of these positions, we're going to run the entire SQL run loop. We have our target, which we will set up at the top. And then we have I as our position. Now we're going to get this return value. And if the return value doesn't return with anything, then we're going to break out of the loop, because that means that we exhausted all the possible characters for the password, which means we're at the end of the string. So we're just going to end it. Otherwise, we're going to go ahead and append or add the return value or the return character to our output. From there, we're going to print. This is essentially going to write to our terminal at every stage if whatever that character is that we discovered. And then once we're done, we're going to do a final print statement once we break out of the for loop. And this is going to print out our finished password, and then it's going to let us know that our script is finished. So sometimes as I'm going through and writing that script, the lab in PortSwigger times out. So I'm going to go ahead and create a new version of the lab. We're going to copy this target. I'm going to paste that in the target value. I'm going to save it. Now we're going to open up our terminal. We can either do that through view terminal, or we can press this control and then little backtick. So I'm going to open up our terminal. I'm going to change to the directory where I saved this script. And then I'm going to run Python blind SQL.py. So I'm going to run this, I'm going to speed it up, and then we'll talk about the results once we're done. And we're back. All right, that took a while. If you're gonna run this script, might as well get up and go grab a coffee. Every single one of these had to be their own individual request, and the application only responds so quickly. So yeah, now that we have our password, we can go ahead, copy that, and log in. So I'm gonna copy this, jump to my account. Paste that in, and congratulations, you solved the challenge. Awesome. This is how you exploit content-based blind SQL injections. Now, this type only works when you have an A/B test on different returns made by the application for true/false values. So in this case for us, it was this welcome back message. Next, let's take a look at how you can handle blind SQL injections when the content doesn't change between page requests. And that's going to get us into time-based SQL. Next, let's take a look at how we can handle blind SQL injections when the content doesn't change between page requests. We're going to keep things going with another PortSwigger lab. This time, we'll target the blind SQL injection with time delays and information retrieval challenge. This one is exactly like the first one we did, but the key difference is that we don't get a welcome back message. In fact, there isn't any difference in the response showing us whether the SQL injection worked or not. But there's still something else we can do. Instead of looking for differences in the response, let's change the response time. See, SQL has a function called sleep, and it's present in all different forms of SQL. For MS SQL, we'd use benchmark, and in MySQL, we would use sleep. But this is a Postgres database. We can tell from previous challenges, but if we didn't know that, we could try each of the different sleep functions to see which ones worked. Let's check it out. I'm gonna go ahead and open up Burp and send to repeater. And I'm gonna go ahead and do a single tick to close out the string. I'm gonna do these two pipe characters in order to concatenate our result. We're not actually requesting any information, but according to SQL, it thinks we are. So that's why this is useful. And then we're gonna do PG sleep 1 second, and then dash dash to close out the rest of the request. And you can see that it takes, in the bottom right corner, 1,223 milliseconds. So this is how we can adjust our response. I'll actually set this to 3 seconds. I'm gonna go ahead and click send again. And this is gonna take 3,000 milliseconds. So we can tell on a truth value if something is true by the amount of time it takes. Here's what that looks like. So if I do select case when, you can also use a if then statement, but case when seems to be a little bit more reliable. We'll set our truth value 1 = 1, then PG sleep for 1 second. Else PG sleep for 0 seconds. Then we're gonna end and close. So 1 = 1 is true, so this should sleep for 1 second. I'm gonna go ahead and run this. And there's our 1 second. Now, if I set this to 1 = 2, which is a false statement, I'm gonna go ahead and click send. It returns almost immediately. So that's how we can do our A/B testing with time-based delays. So let's craft our A/B test. Now, earlier when we were looking at content, we needed to do the substring, and then we would use our A/B test from there. So in this case, we're still going to do our substring, but we're gonna continue with this case when. So we're gonna do select case when, and then where we had our 1 = 1 or our 1 = 2, we're going to nest another select statement inside of here. And this is going to be our substring. So select substring username 11 from users, where username equals administrator equals A. A is the first character, and so that's why we're using that. Then PG sleep 1, otherwise PG sleep 0. So I'm going to go ahead and click run on this. This should be our true statement. And you see it takes 1 second. And then if I change this to B, this is a false statement, returns almost immediately. And with this, we go right back into the same process we used earlier for the content-based responses. Now, we could use Burp Intruder for this too, but let's go ahead and repurpose our first script to look for time-based SQL injections. So we're only going to make a few changes. In fact, I'm going to save this as a new script. So I'm going to go ahead, save as Blind SQL 2. I'm going to save that. And so our first change is going to be this select statement. We don't want the or select ASCII anymore. We need the case when. So I'm just going to easily grab this from here. And create a new SQLi string. I'm going to set our character, just like we had before. I'm going to set our position, like before as well. I'm going to change this to password, and this needs to be wrapped in ASCII. I need to decide how long I want it to sleep. I think 1 second will be good enough. And then I'm going to set a timer delay to look for. That's going to be our 1 second. So next we need to scroll down to our get request. And instead of find string, we're going to change it so that it will track our time. So to do that, we're going to do response elapsed total seconds is greater than our timer. Our timer is set to 1 second, our sleep is set to 1 second. So as long as it takes 1 second or more, or I guess strictly more than 1 second, then what it's going to do is it's going to return 1. If it takes less than 1 second as a response time, it's going to return 0. And with that, we should be good to go. So I'm going to go ahead and change our target to the current target. So let me grab this URL. I'm going to change this target, go ahead and save. And now I can go to view and run this in our terminal. Perfect. So now we have the new password. We can just copy this and paste it right into the terminal, or right into the login page, if I can remember the copy keys. All right, so we go to my account, administrator, paste, and we're in. Congratulations once again. Awesome. In this video, we learned how even blind SQL injections can give us some juicy information from the database if we know where to look. First, we had to find a way to perform A/B testing and turn our SQL statements into true/false questions. From there, we decided to either do a content-based or time-based injection, depending on the type of response the application gave us. And then finally, we went over how to script our own tools to steal credentials from the application. Now, we covered a lot, but we're still not done yet. In the next video, I'm going to show you how to turn this into this, and then into this, to make your scripts that much faster. I'll see you next time.